Okay, in 5.3 we're getting introduced to what's called slope-intercept form. And you may have seen this equation around a few times before, y equals mx plus b. It is the building block of all 8th grade math. What you want to be aware of with this formula is this m really represents the slope and this b represents your y-intercept. Just to make a connection, you want to remember that slope is your rise over run, and rise over run, which means the same thing as your change in y, how your y changed over how your x changed. A vocab word that we haven't really utilized too much is this y-intercept. And how I want you to define y-intercept. It is the place on the graph where the line crosses the y-axis. So I'm just going to write where the line crosses the y-axis. Now some of us might be confused, what's the y, what's the x? The y-axis is the nice tall axis. I always think y stands nice and tall. And the x-axis is the more horizontal one. It's trying to get flat. Okay? So y-intercept is really where the line crosses the axis. And I'm just going to do a couple examples for you. If we had a line that crossed the graph right here, I would want to say, what is my y-intercept? Well, it looks to me like my y-intercept is, here's -1, it looks like it's on -2. So I'd say my y-intercept is -2. Another example, let's say that I crossed the y-axis right here. And I would say, what is my y-intercept? And my y-intercept looks like I'm at 1, 2, 3. My y-intercept is 4. I would just say my y-int is 4. So those are some skills that are really important for you to recall with mastery of today's lesson. The first thing that we're going to need to be able to do is determine slope and intercept from the slope-intercept equation. Okay? What you again need to keep in mind is whatever is in front of the x is our slope. And this last term over here is our y-intercept. So if I look at this equation, y is equal to 3x plus 2, and I want to identify what's my slope. I'm looking what's in front of x, and it looks like my slope is 3, which is also, we would say 3 over 1. And then looking at that second point, our b, our y-intercept, it looks like our y-intercept is a positive 2. So my slope is 3 there, my y-int is positive 2. Looking at this next line, I have y is equal to -4x minus 2. And if I want to know my slope, I'm looking what's right in front of x. It looks like my slope is a -4. And I want to see what my y-intercept is. And this is where it gets tricky. It's not positive 2. You need to view this as a whole. My y-intercept is actually -2. And how I can remember that is if you subtract, it's just like adding a negative. That's really messy. It's just like adding a negative. Okay? But I just kind of view it as one whole. This is -2. Right, another example. We have y is equal to 2/3 x plus 5. Again, my slope is what's in front of x, so my slope looks like it's 2/3. My y-intercept is what's being added or subtracted. It looks like my y-intercept is positive 5. So that's concept number 1 that we need to master in 5.3. So we need to be able to identify what is slope-intercept form of a line that's right up here, y equals mx plus b, being able to distinguish that what the slope is and what the y-intercept is. And then if we were given a line in slope-intercept form, that just means y by itself, we can identify our slope and y-intercept. And that's what we did with all of those examples. Next concept we'll want to learn is creating an equation given our slope and our y-intercept. Our goal is to always get into y equals mx plus b form. This again is called slope-intercept form. So if we want to get it into slope-intercept form, all we need is the slope and the intercept, and then just plug them in where they're supposed to be. So looking at this first example, if I have a slope of 3 and a y-intercept of 4, well then I want to get it into y is equal to mx plus b form. Well, my slope is 3. My slope is actually m. So that's going to go where the m is. And my y-intercept is negative 5 is going to go where the b is. I can pull it all together. Y is equal to 3x plus a negative 5. We never keep it like that. We always want to fully simplify it. So we just write y equals 3x minus 5. The next one, we got a slope of negative 2/3 and a y-intercept of 5. We want to write that into an equation.
One last final announcement, please excuse the interruption.
We want to write it as y is equal to mx plus b.
The district has called off all evening activities. Again,
Noticing that my slope is a negative 2/3 and my y-intercept is 5, I can write this as y is equal to my slope, that's negative 2/3 times x, plus my y-intercept. My y-intercept is 5. I'm going to do one more example with you. If I had a slope of negative 1 and a y-int of, let's say, negative 4. Again, I want to get it into y equals mx plus b format. This is my slope. This is my y-int. So I would say y is equal to my slope, which is negative 1 times x, plus my y-intercept, which is negative 4. Simplify this down. Negative 1 times x would just turn into negative x, plus a negative turns into subtract. My equation is y is equal to negative x minus 4. That's the second concept. So again, our first concept, identify slope and y-intercept. Second concept, we want to make the equation given our slope and y-intercept. Our last concept of today is to create an equation from a graph. So our last concept is creating an equation from a graph. Our first step is to identify what our slope would be. Reminder that slope is your rise over your run. Slope is also equal to our m for our y equals mx plus b. That's always something we have to keep in mind. What we're looking for is our slope-intercept form, which is y equals mx plus b. Our second step is to identify where the y-intercept is. That's where it crosses that y-axis. And lastly, we get into slope-intercept form. So I just want to give an example. I'm just going to draw a line here. I'm going to make it a little bit neater. Okay, if I had a line like this, now pretend that this wasn't really there, and I had no idea what it really went through. So my step one is I want to identify slope. I'm not given 2 points. So I want to find 2 perfect points. It looks like this is a perfect point, and it looks like this is a perfect point. So I need to find out what is my rise over run. So it looks like I went up 1, and then I went over 1, 2, 3. So my slope is 1/3. My y-intercept is just where we cross that y-axis at. It looks like I crossed it at 1, 2, 3, 4. My y-int is 4. Pull it all together, that's step 3, and I get y equals m, which is 1/3 x, plus my y-intercept, which is 4. I'm going to do another example. Okay, looking here, Again, I'm not given any points, so I just want to find some nice perfect points. Looks like those two are perfect. You might choose different ones than I do. In step 1, I want to find my m. So again, m is going to be a fraction. It looks like I'm going down 1, 2, 3. It looks like I went down 3 and over 2. So my slope is down 3 over 2. In my y-end, that's my second step. Identify my y-intercept. And I cross the y-axis at -2. Step 3, pull it all together. And I get y is equal to m, which is -3 over 2, times x plus the y-intercept. Simplify that. Y is equal to -3 halves x minus 2. So we've learned 3 concepts today. We learned what slope-intercept form is. That is our y equals mx plus b. What's in front of the x is our slope. What's behind it is our y-end, right here. We learned how to identify it given an equation. So given an equation, I can distinguish that the slope is what's in front of x and the y-intercept is what's to the right. We've learned to create an equation given our slope and y-intercept. So here, if we had a slope of 3 and a y-intercept of -5, I can just turn that in, plug everything in the slope-intercept form. Lastly, the last concept that we went over is how to create an equation from a graph. The first thing we need to do is identify slope, identify your y-intercept, and get into slope-intercept form. I hope that helps you with your first half of 5.3.